Welcome back, everybody. Today's deep dive is all about image augmentation.
Ooh, image augmentation.
Yeah.
Cool stuff.
Yeah, it's this technique in deep learning, and it helps computer vision models get good at, actually seeing things.
Yeah, it's kind of like a training montage for your computer vision model, right?
Yeah.
Like we want it to be able to recognize a stop sign in a blizzard or, in bright sunshine, or even like if it's half hidden behind a tree,
Oh, wow.
we want it to be robust.
Yeah, so that's where image augmentation comes in, right? It's basically just making altered copies of your training images, creating a ton of extra examples for your model to learn from.
Yeah, and it's not just about having more data, which is what people think.
Right.
It's about having more diverse data.
Right.
So imagine trying to learn a language.
Yeah.
But you're just reading like the same page of a book over and over again.
Right.
You wouldn't get very far.
Yeah.
You need to be exposed to different words and sentence structures and contexts.
Flourish.
And that's what image augmentation does for computer vision models.
So instead of memorizing specific pixels, they're actually learning to identify features and patterns that are consistent across variations.
Exactly. And that makes the model way more robust and able to handle the unpredictability of real-world images.
Oh, for sure.
Right. It's like the difference between someone who can only identify a cat in a perfectly posed photograph,
Right.
and someone who can spot a cat like hiding in a bush.
Yeah. Yeah.
That's really what we're going for.
Yeah. So let's dive into some of these techniques that make this all work.
Okay, let's do it.
I'm curious about this category called geometric transformations.
Okay.
What exactly are we transforming here?
Well, we're playing around with the image's shape and position.
Okay.
So think of it like those old photo booths where you can squeeze your face into funny shapes.
Right, yeah.
We can rotate an image, shift it up or down, flip it like a mirror image. We can even make it look like it's leaning like the Tower of Pisa.
Oh.
All of these things change the geometry of the image.
Oh, so even though it's the same image, it looks different to the model.
Exactly.
So like if we took a picture of a car and flipped it horizontally, is it actually going to help?
Absolutely. Yeah, it might seem simple, but to the model, it's a completely new perspective.
Okay.
And since cars in the real world aren't always facing the same direction,
Right.
that flipped image becomes valuable training data.
Gotcha.
It's all about exposing the model to as many different perspectives as possible.
Okay, I'm starting to get it. Now, what about these color space transformations?
Okay.
What are we doing with the colors here?
So this is where things get really interesting.
Okay.
So instead of just moving the image around,
Uh-huh.
we can actually tweak the colors and the lighting.
Gotcha.
So think about, adjusting the brightness on your phone screen.
Right.
You're essentially performing a color space transformation.
Oh, okay.
Right. We can also tweak the contrast,
Okay.
like making the darks darker and the lights lighter,
Oh.
or even like play with the color balance.
Yeah.
Shifting the hues slightly.
Interesting.
Yeah, all sorts of fun stuff.
So if a picture was taken in like really harsh lighting, you could use color space transformations to make it look like it was taken in like soft, even light.
Precisely. And by doing that, you're teaching the model to recognize that object under different lighting conditions.
Oh, okay.
It's like showing your model a bunch of pictures of apples,
Mm-hmm.
but they're in different light, like in the shade in direct sunlight under fluorescent lights.
Right.
That way, when it sees an apple in a new environment, it won't be fooled by the different lighting.
Makes sense. So we've messed with the shape and the colors.
Right.
What else can we do to augment these images?
Well, believe it or not,
What?
sometimes adding a little bit of noise can actually help.
Wait, noise? Wouldn't that make the image worse?
You might think so.
Yeah.
But think about it like this, right? In the real world,
Yeah.
images are rarely perfect,
That's true.
right? You might have a little bit of static on your TV screen or a grainy photo taken in low light.
Uh-huh.
By adding noise to our training images, we're teaching the model to ignore those imperfections and focus on the important features.
So it's kind of like giving it a more realistic view of the world.
Exactly.
I never would have thought that adding noise could be a good thing.
Yeah, there's a lot of counterintuitive stuff in image augmentation.
Interesting.
But yeah, it's all about preparing the model for the unexpected.
Okay.
So we have things like Gaussian noise, which is like adding subtle speckles.
Okay.
And then there's salt and pepper noise, which is like randomly sprinkling black and white pixels throughout the image.
So we've got all these ways to transform the shape, play with the colors, and even add noise. What other tricks do we have up our sleeve?
Well, there are a few techniques that don't really fit into those categories.
Okay.
One is called random erasing.
Random erasing.
Yeah, it's exactly what it sounds like.
Okay.
We randomly erase parts of the image.
Okay, but wouldn't that make it harder for the model to see what's going on?
It might seem that way,
Right.
but actually what it does is it forces the model to focus on the remaining parts of the image and try to fill in the gaps.
Oh.
And this helps it learn more about the overall structure of the object and become less reliant on specific details.
I'm starting to see how much thought goes into choosing the right techniques.
Yeah, definitely.
It's not just random image manipulation.
No.
It's a carefully considered process.
For sure.
So we've covered a lot of ground, but we're just getting started.
Yeah.
Stay tuned, because we're going to dig even deeper into the how and why of image augmentation.
This could be good. You know, it's amazing how much we can manipulate an image
Yeah.
and still have it be recognizable.
Totally.
It really makes you think about how our brains process visual information.
Right. It's almost like we're tricking the model into learning more than it would from just the original image alone.
Exactly. And that brings us to something that our sources highlight a lot, which is the importance of augmenting segmentation masks,
Okay.
along with the images themselves.
Segmentation masks. Now, I'm not familiar with that.
Okay, yeah,
Can you explain what that is?
of course. So imagine you're training a model to identify different parts of a car, right?
Okay.
Like the wheels, the windshield, the doors.
Yeah.
A segmentation mask is like a color-coded overlay
Uh-huh.
on top of the image.
Okay.
So each part of the car would have a different color, clearly outlining its boundaries.
So it's like a map that tells the model exactly where each object is located in the image.
Precisely. It's like teaching the model to not only recognize a car,
Okay.
but to also understand its individual components.
Gotcha.
Now, here's the thing, right?
Yeah.
When we augment the image,
Yeah.
we need to apply those same transformations to the mask.
Okay.
So if we rotate the image, we need to rotate the mask in the same way.
Right.
Otherwise, the mask won't align with the objects in the image anymore.
That makes sense. It's like if you were putting together a puzzle and someone moved all the pieces around without telling you. It'd be impossible to complete.
Exactly. If the mask and the image aren't aligned,
Right.
the model gets confused.
Yeah.
It's like trying to learn a dance routine, but the music is out of sync.
Right.
So to make sure the model is learning correctly,
Yeah.
we have to keep the image and the mask in perfect harmony.
Gotcha. So it's not just augmenting the image, it's augmenting the entire data set
Exactly.
in a way that makes sense.
Right. And our sources actually give an example of a custom augmentation function that applies those same transformations to both the image and its mask.
Wow.
It's like having a synchronized swimming routine for your data.
I love that analogy. Speaking of putting things together, how do people actually implement image augmentation?
Oh?
Is it something you have to code from scratch every time?
Thankfully, no.
Okay, yeah.
There are some incredibly useful libraries that make implementing image augmentation much easier.
Okay.
So our sources mentioned a few like Albumentations, imgaug, and torchvision transforms. These libraries are packed with ready-made functions for all sorts of augmentations.
So they're like toolboxes for image manipulation
Precisely.
with all the tools you need to get the job done.
Exactly. And they integrate seamlessly with popular deep learning frameworks,
Oh, wow.
like PyTorch.
Okay.
You can even incorporate augmentation directly into your data loading process.
So instead of creating a whole separate set of augmented images, you can do it on the fly as the model is training.
Exactly. This saves a ton of storage space and makes the training process much more efficient.
Wow.
It's like having a personal chef who prepares fresh food for you every day,
Oh, nice.
instead of having to eat leftovers.
Yeah, nobody wants to eat leftovers.
Exactly.
I can't help but wonder, are there any downsides to using image augmentation? It sounds almost too good to be true.
Well, it's important to remember that image augmentation is a powerful tool.
Okay.
And like any powerful tool, it needs to be used responsibly.
Makes sense.
So there's always the risk of overdoing it.
What do you mean by overdoing it?
If we apply too many augmentations
Uh-huh.
or make the transformations too extreme,
Right.
we risk creating images that are so distorted that they no longer resemble the original object.
Oh, so like stretching a picture of a cat so much that it looks like a snake?
Exactly.
Yeah.
And then the model may start learning the wrong things from those distorted images.
Right. It's all about finding the right balance, right?
Exactly. The key is to apply augmentations that introduce realistic variations
Uh-huh.
without fundamentally changing the nature of the object.
So it's not just a matter of throwing every possible augmentation at the model and hoping for the best.
Right.
There's a real art to it.
Absolutely. And that brings us to the importance of experimentation and validation.
Okay.
Our sources emphasize that there's no one-size-fits-all approach to image augmentation.
Okay.
The optimal strategy will depend on the specific data set and the task at hand.
So you can't just copy and paste an augmentation pipeline from one project to another and expect it to work equally well.
Exactly. It's crucial to experiment with different techniques, try different combinations, and fine-tune the parameters to find what works best for your particular model.
It sounds like a lot of trial and error.
It can be, but that's part of the fun.
Okay.
It's like being a detective searching for clues and piecing together the best augmentation strategy to solve the case.
Okay, so we've covered a lot of ground on the technical side of things.
Right.
But I'm curious about the bigger picture.
Okay.
What does the widespread use of image augmentation tell us about the current state of AI?
That's a great question. I think it highlights the incredible progress we've made in computer vision,
Huh?
but it also reveals some of the limitations we're still grappling with.
How so?
Well, the fact that we need to artificially augment our data sets
Right.
suggests that our models still lack the ability to learn as efficiently and robustly as humans do.
Right.
We're essentially compensating for their shortcomings by creating a more diverse and challenging learning environment.
So it's like we're giving them training wheels until they can ride the bike on their own.
Exactly.
Yeah.
But who knows, maybe one day these models will be able to learn so effectively
Right.
that they won't need image augmentation at all.
That'd be amazing.
They'll be able to look at a single image and understand all its nuances and variations, just like we do.
That's an exciting thought. But for now, it seems like image augmentation is here to stay.
Absolutely.
Yeah.
It's become an indispensable tool in the world of computer vision.
For sure.
And as our models become more sophisticated, so too will our techniques for augmenting their training data.
This has been a fascinating deep dive into image augmentation.
Yeah, that has.
We've learned about the why, the what, and the how.
Mm-hmm.
We even touched on some of the broader implications.
Yeah, definitely.
And we're not done yet.
No, we're not.
There's still more to uncover, more insights to glean from our sources.
Oh, yeah.
So stick with us as we continue our deep dive into the world of image augmentation.
Okay, so we're back.
Back for more.
More image augmentation. Yeah, we're not done yet.
I'm still thinking about how we're basically creating a custom training program for these AI models,
Yeah.
pushing them to learn and adapt just like athletes,
Right.
training for a big game.
Yeah, it's a great analogy.
It is.
And just like any good coach, we need to be strategic about the training regimen we design.
Yeah.
So our sources emphasize the importance of choosing augmentation techniques that are relevant to the specific task at hand.
So it's not just a matter of throwing every possible augmentation technique at the model and just seeing what sticks. We need to be more thoughtful about it.
Yeah, exactly. So for example, if we're training a model to recognize handwritten digits,
Okay.
rotating the images might not be a good idea.
Right.
Because it could change the orientation of the digits and confuse the model.
Mm-hmm.
But if we're training a model to identify different types of trees,
Okay.
rotating the images could be helpful
Mm.
because it would expose the model to different viewpoints and help it learn to recognize trees regardless of their orientation in the image.
So it's really about understanding the nuances of the data and the specific challenges of the task before deciding which augmentations to use.
Yeah, precisely. It's like, a doctor prescribing medication.
Right.
They wouldn't prescribe the same thing for every patient.
Right. Of course not.
They would consider the individual symptoms, medical history, and other factors before making a decision.
Right.
It's the same with image augmentation.
Okay.
We need to tailor the approach to the specific needs of the model and the data we're working with.
Makes total sense. Are there any other pitfalls we should watch out for?
Well, one common mistake is going overboard with the augmentations.
Okay.
It's tempting to think that more is always better,
Right.
but that's not necessarily the case.
Sure.
If we apply too many augmentations or make the transformations too extreme,
Yeah.
we risk creating images that are so distorted that they no longer resemble the original objects.
Right. So it's like overtraining an athlete. If you push them too hard, they could get injured or burn out.
Exactly.
Oh.
It's all about finding that sweet spot, that Goldilocks zone, where the augmentations are challenging enough to help the model learn, but not so extreme that they distort the data and hinder its progress.
It sounds like a lot of experimentation is needed to find that right balance.
It is, and that's one of the most exciting aspects of image augmentation.
Okay.
It's an ongoing process of discovery and refinement.
Right.
Our sources stress the importance of using validation sets and metrics like accuracy and precision to evaluate the effectiveness of our augmentation strategies.
So it's like a scientist conducting experiments, testing hypotheses, analyzing results to see what works.
Exactly.
So we're constantly tweaking and adjusting the augmentation pipeline based on how the model is performing?
Absolutely. It's an iterative process that involves careful observation, analysis, and a willingness to adapt and change course if needed.
Gotcha.
There's no one-size-fits-all solution.
For sure.
And what works best for one data set might not work as well for another.
It sounds like a lot of work, but also incredibly rewarding when you see the results.
It is.
Yeah.
There's a real sense of satisfaction that comes from seeing a model's performance improve as a result of the augmentations you've carefully selected and fine-tuned.
Well, I think we've covered just about everything there is to know about image augmentation.
I think so too.
We went from the basics to the more nuanced aspects. I feel like I have a much better understanding of how it works and why it's such a valuable tool in computer vision.
It's been a fascinating journey. And as our models continue to evolve, I have no doubt that we'll continue to develop even more sophisticated and effective techniques
Oh, right.
for augmenting their training data.
For sure.
Who knows what the future holds?
Yeah.
Maybe one day these models will be able to learn from images as efficiently and robustly as humans do,
Right.
without the need for any artificial augmentation at all.
That's amazing.
But until then, image augmentation will continue to play a vital role in shaping the landscape of artificial intelligence.
Well, thank you so much for taking us on this deep dive into image augmentation.
It's been a pleasure.
It's been a fascinating exploration, and I'm sure our listeners have learned a lot along the way. So until next time, keep exploring, keep learning, and keep diving deep into the world of AI.